Okay, sorry for the background noise, but we're going to try to do a little bit of the pizza challenge here. So I've come up with a pretend situation that some pizza that exists somewhere is a 14-inch pizza. It's cut only into 6 pieces, which are massive, and it costs $8. And let's talk through the dynamics of the pizza challenge. The pizza challenge asks really a few questions. First of all, it asks, how much crust do you get per piece? It asks how much how big is each piece of pizza by surface area, and then it breaks it down into cost. Okay, so first let's take a look at how much crust do you get per piece. Okay, well, crust is the same as arc length. Okay, and arc length, remember, is S equals R theta, where R is radius and theta is, of course, in radians. Now, this theta is going to come from this right here, this 6 pieces, all right? Because we know all the way around is 360, or all the way around is 2 pi. 2 pi and 360 are the same thing. So really, we take 2 pi and we divide it by the number of pieces, and that gives us theta, which ends up being 2 pi over 6 is the same thing as pi over 3. Okay, so that's our theta. Now, radius, if the diameter of the pizza is 14 inches, then radius is clearly 7 inches. So therefore, the arc length is equal to 7 times pi over 3 inches, which would be the same thing as 7 pi over 3. Now, of course, I didn't bring a calculator with me, but 7 pi over 3 is, however, you put that into a calculator. I know that 2 pi would be 6.28 roughly, and so 7 pi over 3 is going to be a little bit bigger than that. I don't know how big. 7 point something. So anyway, and so that would be what we're saying. We're saying that each piece of pizza has somewhere over 7 inches of crust, okay? So as you picture the piece of pizza, I'm saying that as we go along this edge right here, as we go along here, okay, that is over 7 inches, okay, if we measured that. That's what we're talking about. So that's the size of crust for that pizza. You get over 7 inches of crust per piece. Okay, the second part, or the second question, deals with sector area. It deals with, hey, how big is a piece of pizza by surface area? And so size, or I don't know, I want to say quantity or size of a piece is sector area, which is equal to 1/2 radius squared times theta. Okay? Well, we have all of our information. We know what theta is, and we know what the radius is, so we just plug all that in. And we say area is equal to 1/2 radius, which is 49, because it's 7 squared, times theta, which is pi over 3. Put all that together, and we get 49 pi over 6. Now, what I should do is I plug that, and that's in square inches. Because remember, the radius was 7 inches, so that's squared, and 49 inches squared, or 49 square inches. Excuse me. So all that to be said, when this is converted into a decimal approximation, which is what you should do, then you get an idea of ballpark of how many square inches make up each piece of pizza. And that would be like if you're looking down on the pizza, like how many square inches. We're not talking about thickness. We're not talking about volume. We're talking about surface area here, just on the top surface area. Okay, and so that's how we find the crust length, and that's how we find the size of a piece. Now, the last thing talked about, okay, well, now let's break it down in terms of cost. And so what we do is we take this idea of this $8, and the first thing you have to do is you have to take cost and divide it by the number of pieces. And why you do that is that gives you cost per piece, okay? And then you take the cost per piece and, whoops, too many E's, whatever. And you divide that by the crust length. And what that gives you is dollars per inch, okay? So whatever number that is, it's in dollars per inch. Meaning if you get, let's say you get 0.13. Well, that means you're at $0.13 per inch, or 13 cents. So let's just say, for instance, we got $0.13 per inch. That would be 13 cents for every inch of crust is roughly what you're paying. Now, this is as if you are the price of the piece of pizza was really only buying just the crust, and that's not the case, but hopefully you understand. Okay, but either way, so what you would do is you get your cost per piece. So let's take our example. Our cost is $8. Number of pieces is 6. So now we're down to 4/3 of a dollar is the cost per piece. Okay, and then what you do is you take that 4/3 dollars and you divide it by the crust length. And what was our crust length? Crust length was 7 pi over 3. 7 pi over 3. Okay? And you would simplify that because this is looking hideous. Now I know the 3's cancel out, so what do I get? I get 4 over 7 pi dollars. Okay? Whatever decimal approximation that comes out to be, that is in dollars per inch. That's telling you how much in dollars did each inch of crust cost you. Okay, and then for the last problem, for number 4, we do it the same way, but this time we're not breaking it down by crust length. Right there, we would put the whole surface area or sector area. So we start with the same thing. We take the cost divided by the number of pieces, and that gives us our cost per piece. And then we take that amount, which we already know what that's going to be. It's 4/3 of a dollar per piece. And then we take that amount and we divide it by this surface area, 49 pi over 6. Yikes. If we multiply the top and bottom by 6, I should grab a calculator. That would give us $8 over 49 pi. Okay, and that is in dollars per square inch. And so picture a square inch. A square inch is like the size of a postage stamp, okay? So what this is breaking it down is saying, okay, every postage stamp chunk of pizza is that much money. Whether it's 0.05 something, then that would mean it's about 5 cents. Or if it's 0.23, then it's about 23 cents or whatever. Okay, I hope this makes sense. All I'm trying to do is connect these ideas of arc length and sector to something a little bit more real world. I know the problem itself is a little bit goofy, but hopefully this is enough of an intro to kind of track along. I'm sorry I didn't bring a calculator out with me.